Hello guys, today we're going to go over some more mixed number subtraction examples. I picked up these unusual examples again, where we will take away one whole unit so that you can learn how to solve these examples. So our example looks like this: 8.2 thirds minus 3.4 fifths. We're subtracting mixed numbers. Step 1. So we're looking at denominators. We have different denominators. We bring them to a common denominator. Guys, memorize this algorithm, how you should proceed when you're reading, either adding fractional numbers or mixed numbers. The algorithm is the same. Once again, subtract mixed numbers or mixed fractional numbers. Pay attention to the denominator. The denominators are different. We need to make the denominator the same. The least common multiple for the numbers 3 and 5, you already know it very well, is 15. The additional multipliers are 5 and 3. What is the result? 8 whole numbers. 5 times 2, that's 10. 5 times 3, that's 15. Minus 3 whole. 3 times 4, that's 12. 3 times 5, that's 15. To the common denominator, I'm sure you've learned by now. Now let's pay attention to how to subtract. Let's check. When subtracting, guys, always check. When we're adding mixed numbers, you don't have to check. You add the whole part to the whole, the fractional part to the fractional part. But when you're subtracting, you have to do it. So let's check. 8 minus 3. That's great. You can subtract. But 10 fifteenths minus 12 fifteenths, we've got nothing. So I'm going back to our example. Now, what was I saying? 8 minus 3. It's okay. Everything works out. But 10 fifteenths minus 12 fifteenths, I can't do it. For that reason, I'm going back to our 8. So I take one whole part. 8 minus 1, that would be 7 whole ones. Next step, 2. To 15, I add 10. 15 plus 10, 25 fifteenths. Once again, I take one whole part away from the 8, that's 7. I add 10 to the 15, that's 25. Don't touch the denominator. Minus 3 whole ones, 12 fifteenths. Now I'm going to subtract. Take 3 from 7, that's 4 whole ones. And from 25, I subtract 12, that's 13 fifteenths. And we've got it exactly right. And let's do one more example to reinforce it. Let's take a bigger number, 25.5 twelfths minus 13.17 eighteenths. Once again, step 1. Let's pay attention to the numbers. These are mixed numbers. We have different denominators. We need to subtract, so we bring them to a common denominator, 12 and 18. Let's do the math. 18 is not divisible by 12. 18 times 2, I get 36. I check. 36 is divisible by 18? Yes, it does. 36 divided by 12? Yes, it does. So I write down the number 36. The additional multipliers here are 3. 36 divided by 12, 3. 36 divided by 18, 2. The result is 25 whole. 3 times 5 would be 15. Try 12, 36 minus 13 whole, 34. You note, again, I always count. I always say 25 minus 13, yes, all right, that would be 12, but from 15, we can't take 34 away from 15. So, I'm going back. 25, take away one whole part. How much does that work out to be? 24, add 15 to 36. 36 plus 15 is 51. And the denominator is 36. That's the most important part of doing this subtraction. Minus 13 whole 34, 36. Now we have to subtract. From 24, I subtract 13. That's 11. And 51 minus 34 is 17. 1736, and that's our answer. So guys, in order to subtract mixed numbers, you always follow the same algorithm. First, bring to the common denominator. Second, check whether from the first number, from the numerator, can subtract the second numerator. That is the numerator of the second fractional number. If it is impossible to do, then you resort to this algorithm, and as a result, you always get the right answer. In the next lesson, we'll look at a couple more examples. And that's all for today. Goodbye. See you again.